This is the first video in my series on three-phase transformers. In this video, I will be looking at the theory behind this topic, which you will find, I'm sure, much less complicated than expected. You can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan store at this web address. Three-phase power has become the standard for power transmission and distribution today. Three-phase power generation, transmission, and distribution is advantageous over single-phase power for the following reasons. Three-phase power distribution requires lesser amounts of copper or aluminum for transferring the same amount of power as compared to single-phase. The size of three-phase motor generator sets is smaller than the single-phase motor generator of the same rating. Three-phase motors are self-starting as they can produce a rotating magnetic field. The single-phase motor requires special starting windings as it produces only a pulsing magnetic field. In single-phase motors, the power transferred in motors is a function of instantaneous current, which is constantly varying. Hence, single-phase motors are more prone to vibrations, whereas in three-phase motors, the power transferred is much smoother and much more uniform throughout the cycle. Hence, there's fewer vibrations to be concerned about. Mainly for these reasons, it's found that the generation, transmission, and distribution of electric power is more economical in three-phase systems than in a single-phase system. In order to understand and work with three-phase systems, we work with voltages and current vectors that are derived from single-phase values that are sinusoidal, and all sinusoidal waveforms, of course, are repetitive. In an AC power system, the power source will supply a voltage that is a sinusoidal wave of one particular frequency, usually 60 cycles per second. The voltage starts at 0 volts, peaks at plus A volts, travels through 0, and peaks negatively at negative A volts, then returns to 0. It repeats itself 60 times a second. When mathematically modeling a sine wave such as V is equal to A sine omega t, it can be considered to be directly related to a vector of length A revolving in a circle with an angular velocity of omega. V can be represented by a revolving vector where its magnitude is A, its angular velocity is omega, and the angle of the vector at a particular time is given by omega t. When considering two sine waves that are not in phase, one wave is often said to be leading or lagging the other. This terminology makes sense in the revolving vectors pictured here. The blue vector is said to be leading the red vector, or conversely, the red vector is lagging the blue vector. These vectors could be current or voltage or one of each. If the blue vector is voltage and the red vector is current, then the current is said to be leading the voltage, or conversely, the voltage is lagging the current. In a utility power grid, omega is 60 cycles per second, or CPS. In some countries, such as Europe, this is usually 50 cycles per second for the power grid there, but here in North America it's 60 cycles per second. All voltages and currents are vectors, all are rotating at the same angular velocity omega, and all may be mathematically dealt with but must follow the rules for vector analysis. Because these vectors have this added property of angular velocity or rotation, they are renamed and known as phasors. When considering three-phase power generation, you can assume that it's made up of three single-phase generators connected together on one terminal. The generated voltage vectors or phasors are 120 degrees apart and rotating counterclockwise at 60 cycles a second. The loads can be connected in various configurations. Shown here is a Y-connected configured load. However, the load can be any configuration. Three-phase transformers may be considered as three individual transformers. The primary side will take on the phase of the voltage applied to it, and the secondary will be the mirror image of the primary. However, the relationship of one transformer to the other is dependent on how they are connected together. As in this case, the primary side is connected in a Y configuration with the grounded neutral, and the secondary is also connected in a Y configuration with an ungrounded neutral. You will find more on these configurations and connections in my course entitled Electrical Three-Phase Power Transformer Fundamentals. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. One of those products is the EcoFlow Delta Pro Ultra. The EcoFlow Delta Pro Ultra is one of the most versatile whole home backup solutions that has just been introduced to the market. This backup power system is designed for both extended outages and daily use. With an unrivaled capacity of 6 kilowatt hours, 7,200 watts output, and 5.6 kilowatts solar input, a single unit can run your entire home. With EcoFlow Smart Home Panel, you get an uninterrupted power backup experience with automatic switchover, energy consumption monitoring, and lower electricity bills. This unit is not driven by gas or diesel generation, but uses the battery storage unit that is charged when the utility is available. This means that the unit can be placed indoors, and it is virtually silent when operating. It has a stackable design that can be expanded to increase output in only minutes. Compatible with various energy sources, from solar to gas, to meet your ever-changing power needs. To obtain a discount code for 5% off on all EcoFlow products and more information on this subject, and pick up your free digital copy of The Ultimate Guide to Residential Standby Generators. Simply fill out the information requested when you go to this website, https://bit.ly/3 Before we end this video, I want to repeat the connection to my free copy of The Ultimate Guide to Residential Standby Generators and the 5% discount code for all EcoFlow products. Also, here is the connection to obtain a free copy of my 50-page
electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my Stan store.